Every time you use an AI, doesn't matter if you're searching for a picture or asking a chatbot some super complex question, you're plugging into this massive, hidden physical world. It's a world of servers and cables and cooling systems that right now is going through a once-in-a-generation revolution. And it's all because of our crazy, insatiable demand for artificial intelligence.
Okay, let's just start with a number it's pretty staggering. According to the International Energy Agency, the amount of electricity that global data centers use is on track to literally double by 2026. And what's the main driver? You guessed it, AI. This isn't just a little bump. We're talking about an absolute explosion in energy demand.
And that explosion, it's pushing the physical backbone of our digital world to its absolute breaking point. You see, the way we've built the cloud for the last 20 years, it just wasn't made to handle the kind of computational thirst that modern AI has. It's forcing a total reinvention, right from the ground up.
So, that brings us to our first big topic, the AI infrastructure crunch. We're going to dig into why exactly the traditional data center model is starting to crack under the incredible strain of AI's demand for computing power.
Really, this whole story is a tale of two clouds. You had Cloud 1.0, which was built kind of like your home PC, using standardized, off-the-shelf parts that were cheap and you could swap them out easily. But Cloud 2.0, the AI cloud, that's being rebuilt more like a Formula One race car, where every single component is custom designed and co-engineered for just one thing, pure, unadulterated performance. So, where does a rebuild like this even begin? Well, it starts with the connections. Let's take a look at how the very fabric of the cloud, the network that stitches all these data centers together, is being completely re-architected. All right, so there's a key term we've got to get our heads around here. It's the Data Center Interconnect, or DCI. The best way to think about it is like a private superhighway system that connects clusters of data centers in one geographic area. Now, this isn't the public internet. It's the private, ultra-high-speed backbone that a cloud provider uses for its own operations. And when you build this superhighway, you've basically got two main options. The old way is the centralized or hub-and-spoke model. All the traffic routes through one or two big central points. It's simple, but man, it can create bottlenecks. The new way is the distributed model with more direct point-to-point connections. It's way more complex, but it offers some seriously game-changing advantages. And when I say game-changing, I mean it. A distributed network can slash latency, that's the network delay, by more than half in a big chunk of cases. Plus, it massively increases the geographic area where you can even build new data centers. So what's the catch? Well, the problem has always been that this approach was just way too expensive and complicated to manage. So what makes it so pricey? You'd think it's all the fiber optic cable they have to lay in the ground, right? Nope. As you can see here, the overwhelming cost comes from the super specialized little components at either end of that fiber, the transceivers. Those are the things that turn electrical signals into light and back again. And that is the exact problem the cloud giants decided they had to solve. Now, this network revolution has a huge domino effect. Once you change the connections, you have to change the buildings themselves. It's not just the digital highways that are changing. The data centers, the actual concrete and steel buildings, are also being completely rethought. The age of building one single, colossal mega data center in a region, that's pretty much over. And why? Well, it's getting harder and harder to find enough land, and more importantly, enough power in one single spot. So the new strategy is to build clusters of smaller, interconnected facilities that are spread out across a region. Of course, this new cluster strategy means you have to build things faster. As this quote shows, companies like Alibaba are moving to prefabricated, modular designs. Seriously, think of it like building with high-tech Lego blocks. This approach can cut the time it takes to get a new facility up and running by up to 50%. But here's the thing. When you pack more and more powerful AI chips into these buildings, you generate an incredible amount of heat. Your standard air conditioning just can't handle it. This has led to some really radical new cooling solutions, like Microsoft's custom-designed liquid cooling Sidekick. It's this unit that sits right next to a server rack, circulating fluid to pull heat directly off their new Maya AI chips. And that brings us down to the most fundamental layer of this entire transformation, the silicon itself. The actual processors that do the thinking for AI are being reinvented. We're moving away from buying off-the-shelf chips to creating completely custom designs. And just look at who the new chip designers are. The world's biggest cloud providers, AWS, Google, and Microsoft, have become some of the most important chip designers on the planet. They're creating their own custom silicon, like Trainium from AWS and Maya from Microsoft, built specifically for their AI workloads. And you also have a whole new wave of startups jumping into this space too. This quote from Ronnie Borkar at Microsoft just nails the new philosophy. It's not about writing software to run on whatever hardware is available anymore. It's about being a systems company, where you design the hardware and the software together in lockstep to squeeze out every last drop of performance. It's all about making 1 + 1 equal more than 2.
And here's why that matters so much. As Sam Altman from OpenAI points out, this deep end-to-end optimization, right down to the custom silicon, that's what unlocks the next generation of AI. It's how you train bigger, more capable models, and, this is crucial, how you make them cheaper for everybody to use.
But here's the twist. This whole thing, this massive, multi-billion-dollar rebuild of the entire cloud, it's not just a race for more speed. There's a much bigger, much more urgent reason behind all this innovation. The absolute, desperate need for energy efficiency. Get this. This is a powerful statistic. According to a study commissioned by AWS, if you run an optimized AI job on their cloud, you can slash the associated carbon footprint by up to 99% compared to running that same job on a typical company's own data center. 99%. That reduction is just staggering.
So you're probably asking, how on earth is a 99% reduction even possible? Well, it comes down to these 4 pillars that connect everything we've been talking about. It's more efficient hardware, those advanced cooling systems, the hyper-efficient custom chips that deliver up to 50% better performance per watt, and finally, a massive, massive commitment to powering the whole thing with renewable energy.
And when I say massive commitment, I mean it. For the 4th year running, Amazon was the single biggest corporate buyer of renewable energy on the entire planet. This is not a side project for them. It's a core piece of building the cloud of the future.
So, let's tie it all together. AI's incredible appetite for power is forcing a complete rebuild of the cloud. We are moving from an era of generic, one-size-fits-all parts to a new world of hyper-specialized custom systems. This change is happening at every single level, networks, buildings, and the chips themselves. And a huge driver behind it all is the urgent need for a more energy-efficient digital world.
And all of this leads us to one final, really important question. As this new cloud gets built from the silicon up, based on custom, vertically integrated systems, the companies designing these new foundations aren't just building infrastructure anymore. They are fundamentally redefining who will own the future of computing itself.